Model A and B, these are the presented by the Bohr model. Atom A and B. Observe these atoms. We observe that there is one proton present inside the nucleus and one electron revolve around the nucleus. Whereas in atom B, we observe that one proton and one neutron present inside the nucleus and around the nucleus only one electron. So, student, can you identify similarities and differences of these atoms? Means, are you able to compare both the atoms? First, we have to point out the similarities. What similarities you observe? Number one, same number of electrons, both having one electron in the valence shell, or outermost shell because they have only one shell. Same number of proton, one proton present inside the nucleus of both the atom A and B. Same atomic number means number of proton present inside the nucleus. So both element A and B having atomic number 1. Now observe the differences. There are two differences. Number one, different number of neutrons. In A, we do not observe any neutron. 0 neutrons are there, no neutrons are there. In B, we observe only one neutron. So, both the atom showing different number of neutrons. Different mass number. Why mass number is different? Mass number means number of proton or neutron present inside the nucleus. In element A, atomic mass or mass number is 1 AMU, where in element B, we observe one proton and one neutron. That's why mass number is 2 AMU. So, are you able to define isotopes? On the basis of above similarities and differences, we can say that both are same element. Are you sure? Isotopes are atoms of an element with the same number of protons and electrons, but different number of neutrons. We can say the different isotopes of an element have identical chemical properties because chemical properties depends upon atomic number and their physical properties are different because physical properties depend on the mass number. We can say that an isotope is an atom that has a different number of neutrons, that is a greater or lesser atomic mass than the standard of that element. We already have learned that atomic number is the number of protons in an atom's nucleus. Now come to the isotopes of hydrogen. There are three isotopes of hydrogen, each and every element having isotopes. First, hydrogen. There are three types of isotopes of hydrogen: protium, deuterium, and tritium. Observe its structure. In protium, we observe one proton and one electron. There is no neutron. In deuterium, we observe one proton, one neutron, and one electron around the nucleus. In tritium, we observe one proton, two neutrons, and one electron around the nucleus. So, what is the main similarities? Both having same number of proton, both having same number of electron, and both having same atomic number. What are the differences? Differences are all the isotopes having different number of neutron. Protium do not have having any neutron, deuterium having one neutron, and tritium having two neutrons, and both having the different mass number. Protium showing is also known as hydrogen 1, deuterium 2 also knowing as hydrogen 2, and tritium 3, also known as hydrogen 3. Protium is the most common hydrogen isotope with an abundance of more than 99.98%. Of the nucleus of this isotope consists of only a single proton. Atomic number, mass number is 1. Deuterium. It is also represented by D. It is a stable isotope of hydrogen. Approximately 0.0156% of all hydrogen found on Earth. Because of the extra neutron present in the nucleus, deuterium is roughly twice the mass of protium. Tritium. It is also known as radioactive isotope. Its mass number is 3 because it consisting of 1 proton and 2 neutron. Naturally occurring tritium is extremely rare on Earth, where trace amounts are found by the interaction of atmospheric cosmic rays. The presence of deuterium gives the water different nuclear properties, and the increase of mass gives it slightly different physical properties when compared to normal water. If water having protium type of hydrogen, it is termed as ordinary water. If water having deuterium type of hydrogen, it is known as heavy water. Now, roughly comparison of physical properties of ordinary water, which having deuterium, protium, and compare with the heavy water, which is also known as consisting of deuterium. Melting point, ordinary water showing 0.0 degrees Celsius, whereas heavy water showing 3.81 degrees Celsius. Melting point showing 100 degrees Celsius, whereas heavy water melting point showing 101.42 degrees Celsius. Density observed at 25 degrees Celsius. We observe the density of ordinary water is 0.99701 gram per centimeter cube, whereas heavy water showing 1.1044 gram centimeter cube. So all the values are a bit higher or greater than ordinary water. It is due to the physical properties. This physical properties is due to the heavier mass number. Come to the isotope of hydrogen. Hydrogen showing 3 types of isotopes. Carbon showing 3 types of isotopes: carbon 12, carbon 13, and carbon 14. Carbon 12 showing 6 proton, 6 electron, and 6 neutron, whereas carbon 13 showing 6 proton, 6 electron, and 7 neutron, and carbon 14 showing that 6 proton, 6 electron, and 8 neutron. In fact, the carbon 12 isotope make up 98.9% of carbon atom. Carbon 13 makes up 1.1% of carbon atoms, and carbon 14 makes up just a trace of carbon atom as they are found in nature. So, carbon showing 3 types of isotopes: carbon 12, carbon 13, and carbon 14. Come to the next, chlorine. Chlorine showing 2 types of isotopes: chlorine 35 and chlorine 37. In chlorine 35, we observed that 17 proton, 17 electron, and 18 neutron. Atomic number 17, mass number 35. Whereas in chlorine 37, we observed that 17 proton, 17 electron, and 20 neutron. These 20 neutrons means it is a bit heavier than chlorine 35. In atmosphere, there are 2 stable isotopes: chlorine 35, which is present 75.77% in the atmosphere, whereas chlorine 37 present in the 24.23%, giving chlorine a standard atomic weight of 35.45. Next, isotopes of uranium. Uranium showing different isotopes. We consider only three here: uranium 233, uranium 235, and uranium 238. Atomic number of uranium is 92. It means it having 92 proton and electron. Mass number showing 233, 235 and 238. It means they having different number of neutron. In 233 showing 141 neutron, in 235 showing 143 neutron, whereas in 238 showing 146 neutron. What is the difference between these three isotopes? The number of neutrons. Here we presented a reaction, uh, uranium divided into or decay in two component, that is helium atomic number 2 mass number 4 and thorium atomic number 90 and mass number 234. Now come to the uses. Isotopes having various uses in different field of life. Here we discuss only few of them. Tritium. As you know, it is present in the trace amount. It can be used as a measure water content of a body. Carbon 11. It can be used the brain scanning. Carbon 14. Radioimmunology. Iodine 131. It is also used in the diagnosis of damaged heart muscles and hyperthyroidism. Mercury 197, it can be used for kidney scanning. Phosphorus 32, it utilized for the detection of eye tumors. Iron 59, it used to the diagnosis of anemia. Cobalt 60, it's best using best treatment of cancer. Sodium 24, location of blood clots and circulatory disorder. Gold 198, curing of cancer. Radioisotopes which are useful in industry and in agriculture. Strontium 90, thickness of coating or level of liquid in tanks. There are various type of isotopes are there, each having different properties, and we are using for a specific purpose. Now come to the recap. Isotopes are the element having same atomic number but different in mass number. Why mass number is different? Because number of neutron vary in the same element. Each and every element having isotope. We can define isotopes. The isotopes are atoms of an element with the same number of protons and electrons but different number of neutrons. We discuss isotope of hydrogen. There are three isotopes of hydrogen: protium, deuterium and tritium. Protium having no neutron, deuterium having one neutron and protium having two neutrons. Due to these properties, its physical properties will be changed, and we compare the ordinary water with heavy water. Ordinary water are the water which having protium type of hydrogen, whereas heavy water are the water which having the deuterium type of hydrogen. We compare and observe their physical properties, and we observe that physical properties are a bit higher than ordinary water. Heavy water having higher physical properties than ordinary water. Chemical properties are same. Carbon having three types of isotopes: carbon 12, carbon 13 and carbon 14. Both having same number of proton and electron, but carbon 12 having 6 neutron, carbon 13 having 7 neutron and carbon 14 having 8 neutron. Chlorine. We discussed two types of isotopes of chlorine, chlorine 35 as well as chlorine 37. In chlorine 35 and chlorine 37, both having same 17, number of proton as well as 17 number of electron, whereas chlorine 35 having 18 neutron, whereas chlorine 37 having 20 neutron. Then we discuss isotopes of uranium. We observe here we discuss only three isotopes of uranium, that is 233, 235 and 238. Uranium having high amount of energy due to these nuclear reaction, it produce high amount of energy. Therefore, uranium having a specific chemical reaction by which we can produce energy. Okay, thank you.